All right, so we'll get started today. We're going to be going over the 4-axis milling operations. And I'm actually going to open a couple other part files than just this one to go over the 4-axis standard first. And then we'll go over the 4-axis Pro milling operations, some of the new functionality in the 4-axis Pro that can be really beneficial for adaptive depth of cut, adaptive step over, and being able to set your specific step over that you need to be able to get the correct surface finish that you want on the part. So I'm going to go to my demo files. We have 4-axis rotary with this one. We have 4-axis wrapping group we'll look at as well. If I want to do a pocket like this, also in 4-axis standard. But first, we'll go over indexing. So I'll open up this part file for indexing, and let's imagine as though the stock here is a cylindrical stock, and I'm going to be indexing on all 5 of these sides here. So first, I do what I do every other time for a milling job. I go to the top and I go to CAM. I go to a new job, and I select milling, and I select what type of machine. Now our BC3X mill is a Fanuc-based G-code formatting for the Bobcat 3-axis mill here, but I need 4-axis functionality, so I'm going to go with the BC4X mill. We've got some others in here like the Haas, just to show you. We have a Haas 4-axis mill for A-axis rotation, would be something like this, just like the BC4X mill. Also has A-axis rotation, where it's rotating around the X-axis. And then we have the Haas 4X mill B, which would be the B-axis rotary, which would be around the Y-axis. As if that's the axis we're rotating around. But we're going to do A-axis rotation, BC4X mill. Go to my stock wizard, where we can define our workpiece. If we have our finished 3D model, we click on it here for the workpiece. This can be helpful in simulation to be able to make sure that everything is cut to size. And so after I select my workpiece, I go to the next page where I define my stock. So it starts with a rectangular piece of stock like this. I can change the stock type up at the top from rectangle to cylinder and hit calculate stock. Now it gives me a cylinder around sort of like the long ways of the part here, or I guess more up and down, you could say, and I want it to go long ways. So I changed the extrusion direction here halfway down from Z-axis to X-axis. And then I hit calculate stock again to create the cylinder around the 3D model. This sort of gives us like the smallest cylinder, I guess you could say. So it doesn't really go around all of the features here of the part file. So I changed the bounding options over here up at the top from bounding box to bounding cylinder, and then hit calculate stock again to give me the right stock that I want to use here. And then my last page is my machine setup page, which is where I'm setting my work offset for G54. Normally with 4-axis, it's just going to be here right in the center. And I've gotten this question a lot with customers of, okay, how do I set my work offset in the center of the stock here if I can't touch off my tool at this location? Well, a lot of customers will want to have their machine set up at the top. I don't suggest that, because when we rotate around to the different indexes here, or the wrapping group or rotary tool path as it rotates around, the X, Y, Z moves aren't going to be correct because we're looking at this as if it's rotating around this point. We want it to still rotate around the center point here. And at the machine, what I would recommend is, touching off on the side of the stock and setting the radius of the tool so that you have your X position here. And then for your Z position, I'd touch on top of the cylinder and be able to know what the radius of the cylinder is of your stock to offset for your G54 location. And after that, we'll click OK. So that is how we get all set up for starting our first 4-axis milling operations here. If you guys have any questions, please let me know in the comment section. More than happy to answer anything moving forward. So I go back to my original milling job here, where I've got everything all programmed out with the different indexes. And to start with, I just right-click on Machine Setup 1. And to create an index down in the CAM tree here, I go to Additional Functions. It's about 2/3 of the way down in the drop-down here. Select Additional Functions and then Add Index. It's going to ask me to pick a surface or pick a UCS. So if I pick a UCS, I can pick whatever coordinate system that I'm using. Maybe I'm going 90 degrees in this direction. I think I could do that. I could do that with the front UCS if I wanted to. So we'll see how that looks. I'll pick a UCS. I'll pick front. And you can see this arrow going in this direction. Now this is the correct direction for theoretically my new Z axis, where the tool is going to come down, do the facing operation on this side, and do a pocket operation. If I'm trying to index on the other side, on this side here, to this point, I can click on this reverse button, and you can see it will reverse the arrow. It's in the same direction as the y-axis here. You can see that. So then it would, instead of rotating, we'll say positive 90, it'll rotate negative 90, depending on the direction of the arrow here. I always make sure to make a note of that, because if you are trying to index to this location, you want it to be where the arrow is going out of that surface, normal to that surface. And then I click OK. And then down at the bottom, you'll see the new index system. I right click and then I go to my milling operations as if I'm programming from a machine setup, where you have your drilling, tapping, counterbore operations, mill 2-axis, which I could do facing and pocketing for this, and then our 3-axis milling operations as well. So what I did here is I created an index system on this side here for a facing operation. I then created an index and just kept going around the other 4 sides. This side did a 3-axis roughing operation to rough out this area here. Next indexed to this location. And you can see also, as a side note, you can see the different indexes have a coordinate system with the X and Y axes, and these are flipped. You don't have to worry about that. The only thing that we're concerned about is the new Z axis, which will be, from theoretically from A0 here, this would be like A20 or something like that to get to this location. There's not going to be any output for X and Y because it's not going to reference this X and Y coordinate system. It's going to reference the original coordinate system, just indexed to that location around the A axis. All right, and then the next one, indexing to this location, facing and pocketing, and then facing on this side, facing and drilling on this side. All right, so we'll take a look at the simulation. You can see it facing on each side first. And that is because Bobcat sorts the operations based on limiting tool changes. So it's going to rotate around, and we can actually see the A-axis movement here and where it is in regards to the A-axis. If I go to the bottom right corner, where I currently am. So I'll move myself out of the way. So down at the bottom right corner over here, you can click on this tab, Axis Control, and you can see I'm currently at A54. I can even move these sliders over if I want to move the tool out of the way and see my part. And I can also move the A axis around. This is where the tool's rotating around the A axis. Which brings me to a good point. I can change how the rotation is going to be with the tool and with the stock by going to this up at the top left workpiece stock. I'm changing that to tool. So it's going to fix my view to the tool rather than the stock. So the stock's going to rotate around instead of the tool here. When I hit play, the tool goes back to its location for the next move. And when I pause, I can always move the X, Y, Z, and A axis of the tool under axis control. So here's the first facing operation, the next depth of cut, and then it goes to this side, and it just keeps going to all 5 sides first. Now we're at A negative 90, as we see over here in the axis control page. Then it's moved to A minus 162. Now it's at A minus 234. And then it's got one more side after this, which is A minus 378 to do this 3-axis roughing operation. I'm going to skip the roughing operation for now and get to the 2-axis pocketing. Now you can see it goes to A minus 450. So depending on your machine, it'll keep rotating and keep going past 360, or it can go back to, positive, what would this be? Positive 120. Or minus 120, actually. But yeah, depending on your machine, it'll output the A-axis rotation coordinates specific to what you need. If you don't already have a machine and post-processor for your 4-axis machine, you can go to the page that you're on now, bobcatsupport.com, and under the post-processor tab, you can request a new post-processor. We need a sample program and a list of G&M codes from your machine to know how it needs to be formatted, and we'd be able to make the post-processor or modify one to have one work specific to your machine. All right, so we're almost done here with the simulation. I'm just going to skip to the center drill and the drill operation on this side, where it's peg tapping at each location there, or peg drilling. And once it goes past to the other side, we'll close out of simulation. We'll look at the other 4-axis milling operations. So this is just the basic indexing that we offer to index around a rotary part in 4-axis. This is, again, in the 4-axis standard. Also in the 4-axis standard is our wrapping group functionality here. So on this part, you can see in the milling job, there's a whole lot of different operations. I sort of stood it up first under machine setup 1, did a drilling operation through here. Probably do a pocket, but anyway. Machine setup 2 would be our rotary axis around the x-axis here, with our machine being the BC4X mill again. I did a couple of drilling operations on these sides. Now you can see it'd be really easy to do a drilling operation here with my z-axis pointed in that direction. It's also very easy to do a drilling operation 90 degrees or anywhere else around rotary without having to do an index. So we'll take a look at that first. All I have to do is right-click on the machine setup I'm programming in, go to mill drill hole, and I'm going to change it from standard drill here to cross drill. And then I can select the rotation axis, which is going to be around the x-axis. And then I select the surface of the hole so that it knows the direction of the drilling operation from there. When I click OK, I type in the depth of the hole that I'm drilling. I go through the process of center drill and a drill operation that I'm utilizing here, defining the drill shape, size, the depth. And when I compute, you'll see in the back plot here that it's drilling to this location. So it's going to output, let's see what it outputs in the code here. Probably output a positive 90, I would assume. Nope, a negative 90. So you don't have to create an index in drilling and then select the drill operation. You can do it all in the drill operation by selecting your geometry, selecting cross drill. The other option here is multi-axis drill. That would be for 5-axis machining if you need to index in 5-axis. So just one way to save you time without having to index for drilling operations there. Makes things nice and easy. Next, we'll take a look at doing the profile finish inside of these areas here. So that's, to start that, sort of similar to creating an index, I'm going to create what's called a wrapping group. And so I'm going to right-click on Machine Setup 2. I'm going to go to Additional Functions, and right next to Add Index, there's the option for Add Wrapping Group. I'll select that. I'll check the box Wrapped Geometry, because the geometry is wrapped around the cylinder. If it's laid out flat, I can uncheck this box and tell the software that it's not wrapped yet, and Bobcad will wrap the toolpath around it. And I also type in the wrapping diameter, how I want to wrap the toolpath around the part. I just always click on Use Stock Diameter and it wraps it around the part for me. And then the only other option that I change here is the axis direction, whether it's x-axis or y-axis. And I'm leaving this one here as x-axis for an a-axis rotation. I click OK. And then from the wrapping group, I program from it just like an index. I right-click, go to Mill 2-axis, select my geometry. I'm going to select all of the edges around here. This was wireframe, so I just hold Shift and click to chain select it all. And after that, it's the same type of programming as if I was doing a pocket operation. So I'm going to type in my top of feature and total depth, or just click on the edge for my total depth here. Next page, I'm doing a pocket and a profile finish. Next page, options for tabs, options for a different work offset. Go to my tool page. Maybe make it a little bit smaller so that it'll fit in here. Let's do an 1/8 inch flat end mill. And sort of a side note with the newest version of Bobcad, what I really like is everything is docked here on the side of the software program for programming. And that way I don't have to compute the toolpath right here in the CAM wizard every time to view an updated view of the toolpath. I can click on this compute toolpath button up at the top here, this small button here, and it will update the toolpath so that I can see it and I don't have to compute, go out of the CAM wizard, go back into it. I can compute it in real time. And so my next page, my step over, depth of cut, and all of those settings like a pocket operation, and then setting up my tool for the finish pass. I'll use the same tool here. And then set, if I'm doing a depth of cut, step over, lead in, lead out, and all of those settings for a profile finish pass. And then hit compute. And there's my toolpath wrapped around the part file in 4-axis using a wrapping group. And we'll take a look at simulation here. So again, with this example, I stood it up and did a couple drilling operations. On the side of it, did a couple drilling operations. And then here we get to the wrapping group. Where, again, it's basically just a 2-axis pocket. And then the stock is going to rotate around the A-axis here to give us this 4-axis milling operation. And we're looking at the axis control over on the bottom right here and looking at the A-axis as it rotates around. It's at minus 265 right now, going back to about minus 200 as it goes back and forth inside of that pocket. And all it's doing is Z, and the tool is moving back and forth in the X direction up and down the cylinder as the part's rotating around the A-axis. And then it'll retract and go to the next pocket that I had programmed. Do each depth of cut. And then do the profile finish on both pockets here. All right. If you guys have any questions with the indexing or the wrapping group here, let me know in the comment section. More than happy to answer anything moving forward here. So this is all finished up. We'll close out of simulation. And we'll take a look at the next option in 4-axis standard, and then we'll start getting into 4-axis pro. So this one is rotary. So again, the three main options in 4-axis standard are indexing, to index around a cylindrical stock here, around the different sides. We have wrapping group, where we could do a pocket operation here to generate a pocket toolpath profile finish along the pockets around a turned part like this. And last one here is rotary. So if I have a turned part like this, we're going to look at a basic shape like this, and then we're going to look at a much more detailed shape like this to be able to rough and finish. If we look at it like the 3-axis milling, 3-axis standard is our basic roughing and basic Z-level finish. The 4-axis standard also has a basic roughing, basic Z-level finish, and then the Pro has an advanced rough and advanced finish, just like in the 3-axis Pro. So we'll take a look at the standard first. And again, just like before, I go to the top and go to CAM, start a new job to start this off, go to milling, select my machine, which is going to be the BC4X mill, which has an A-axis rotation, rotary axis. Go to the stock wizard, define my workpiece. These are separate surfaces here, so I'll just window select it. Next page is my stock, and again, it's going to be a cylinder going out in the X direction, and I'll hit calculate stock to make stock around the part here. And then last page is my machine setup for my G54 work offset, and I'm going to leave it here in the center of the stock and click OK. Now I'll go back to my milling job that I created for this one here. You'll see just a basic rotary roughing operation where I can set multiple depth cuts here and set a step over going across. And I found that by right-clicking on Machine Setup 1 in the CAM tree and going to Mill 4-axis Rotary, the one right after Mill 3-axis. Click on that one, select my geometry, which is going to just be the 3D model, and click OK. Next page, top of feature, where it just picks it up based on the top of the stock. Next page, you can see the different available operations where we have 4-axis rotary, we have 4-axis advanced rough, and 4-axis advanced finish. So we'll look at those, which are included in the 4-axis Pro after this one. We're just doing the basic 4-axis rotary here. Next page, setting up our work offset number, setting up some different limits for the posting in multi-axis. Now, we recommend customers just leave these options grayed out. These are just set up by default to what they are set up for the machine. And we can change these settings here for you if there's different limits that we need to set, things like that. First, we'll go to the tool page, and I'm just going to use a 1/2-inch ball end mill. Just let it rough across, sort of like as if I'm turning down the stock, but with a milling tool here. Next page, different cut pattern. So zig is going to step over. Zigzag would be kind of weird, I think, because it'll rotate the part 360 back and forth as it steps over. And also the spiral toolpath here. Just a smooth transition as it steps over, as the stock has a full revolution every time. Our rotary axis here, whether we want to turn the stock around clockwise or counterclockwise. Here's where I can set my step over, an allowance, so I can leave a certain amount of material for the finish pass to clean up. You can see all these options are just like in the Z-level rough in the 3-axis standard toolpaths. Probably only difference here would be setting up the cut interval. So cut interval, cut all would be the stock would rotate around 360 every time and keep revolving around. Setting the cut interval start or end would be, maybe if you want to just cut half of this, you could say 0 to 360 and be able to set a certain interval here. All right. Entry options, just like in the 3-axis standard, if you want to plunge, ramp, or spiral it down into the material, entering into the stock. How you want to compensate for the tool, output for the tool tip or center of the tool, linking for each step over, gouge check page, advanced feed rates, and MDI. So those are all the same sort of settings as our Z-level roughing operation. And in the Z-level rotary that I did here, I set a step over of 100. Yeah, the only thing that I changed with this one would be down at the very bottom of the patterns and parameters, would be checking the box multiple passes, and I can set the number of roughing passes here, just like it shows here. So I can set the number of roughing passes and how far they're going to be spaced out, and a number of finish passes and how far they're going to be spaced out. And we'll take a look at our simulation. So I just used one tool on this one, just a basic 1/2-inch ball end mill, so that I can rough across it a few times and then use the same tool to come back and finish it up. Now you can see down at the bottom right here, we're already at positive 2,000 degrees in the A axis. And as I hit run, it's going to keep going up and up and up, climbing. That number is going to keep climbing here. We're at 3,000. Now we're up to 4,000 degrees for the A axis because it just keeps revolving 360 every time. Some older machines only take a certain limit, just like a limit in every other axis, right? You've got your limit in the X axis at the machine, limit in the Y, limit in the Z. You also have an A-axis limit on some machines. And this machine, the BC4X mill, has a limit of 10,000 degrees, positive and minus. And so if you see A is already at 8,500 degrees, once it gets right before it gets to 10,000, it'll be like 9,999. You'll see it stop. The tool retracts up. The part is rotating the opposite direction now. So it's doing a rewind. And you can see it going from positive to 0. Then it's going to rewind all the way back to minus 9,000. So that we have all of that extra travel in the A axis once it comes back down and does the rest of the milling. And then if it hit right before it hits that limit again, it'll retract and rewind the rotary axis again if it needs to. So just to show you, this machine does that. If you don't need a limit in this regard, you can set it, say that it's infinity for the limit here in the A-axis rotation. But just to show you, we do offer that type of limit in that axis as well. All right, cool. And then we'll close out of simulation. And we'll take a look at the next part file to look at advanced rough and advanced finish in the 4-axis rotary. So, some different options here. Actually, let me do this. Okay, advanced rotary finish. Okay, so there were a few different ways of programming for this. Again, we could do the advanced. I think that would be a good one to cover, the advanced rotary and roughing. Because in this example, we have indexed to A0 and did a 3-axis roughing operation, then A minus 180 and did a 3-axis roughing operation on the other side. You could do it that way, or you could do it in this way we're going to look at here. Right-click on the machine setup, go to Mill 4-axis rotary, select the solid model, and click OK. Next page, top of feature. I'm in millimeter. Let me change that. There we go. Next page, I'm going to select advanced rough instead of the basic rotary operation. Posting, work offset number 1 being G54. Get down to our tool page. We'll use, let's use this. We'll do like a 1/2-inch tool for the roughing here. Next page, just like the 3-axis advanced rough, we have our 4-axis advanced rough basically. So we're doing one directional cutting because it's going to step over as it rotates around. Different types here of offset or offset and spiral. And there we go. So the offset, if we look at it here, it's just going to keep stepping over as it rotates around. Not as efficient here because it needs to step over across here and then it keeps stepping over like this. The offset and spiral, or I guess offset, a better explanation here would be, you can see the offset going around the geometry as it goes around like that. The offset and spiral saves you time where it will spiral around the cylindrical shape like this. And then when it gets into these fins, it'll step over around the geometry, but save us time with the spiral option here. Alrighty, patterns and parameters. Other parameters we have in here would be our depth of cut. We can set an adaptive depth of cut. So let's say, for example, between here and here is 100 thousandths. It'll do an additional pass here just based on like the advanced rough. It'll do an extra depth step knowing that there's another step here to in between the 100 thousandths. And so that's our adaptive depth step. Force floor cuts is another option to force additional floor cuts, just like the adaptive depth step here, your step over, and allowance. So you can leave, let's leave 15 thou on the floors for the finish pass to clean up. And we could take a look. Let's see. It doesn't give us an example of what this is. Number of intermediate steps is a really cool one if you haven't viewed it in the Advanced Rougher 3-axis yet. As it goes down, let's say this is 50 thousandths every time. So we'll start here. If you can see my cursor right here. Starts here, 50 thousandths. Let's say this is 50 thousandths, this is 50 thousandths, this is 50 thousandths. And we want to do... there would be a lot of material built up above the floors here, and as the tool comes back up before it retracts for the next operation, it'll, for number of intermediate steps, if I set it to 1, it'll do an extra step in between each one that I've done to have less material for the stair steps as it comes back with the finish operation. I might show that in 3-axis to get a good understanding of what that does. It's actually really useful, but hard to see in this one. All right, so next page, entry option. If I want to ramp in, linking for each step over, and MDI. So I'll hit compute. And I'll move that up in the list. So this will be first, and then we'll have our 4-axis advanced finish after this. So now you can see the difference. I can move this up here. There we go. Now you can see the difference depending on if I did the index system. It'll try to rough around, go around these areas. This is a bunch of wasted time because my stock is already cut to size here. So these are all just wasted time for retract moves, stepping over, linking moves here. And then we get to our 4-axis advanced rough. It's just going to follow along the contours of the 4-axis part, the spiral toolpath, and spiral around for us and rough it out like that, as if it's a 3-axis advanced rough operation, but rotating around the 4th axis there. All right, and then next is going to be the advanced Z-level finish. Is just like before, just like the advanced rough, but we're doing it in a finish operation here. I select my tool. It's going to be basically, 6mm ball end mill, basically a 1/4-inch ball end mill here. Set my step over. Set my next page is going to be entering into the stock, linking for each step over, Gauss check page, advanced feed rates, and MDI, just like in the advanced Z-level finish in 3-axis. So that's what this one looks like. Just follows along the part there. And that's about it. We'll take a look at the simulation on this one. And then I'll show in the 3-axis rough, I've got another demo file of how it looks with the number of intermediate steps. I don't show that a whole lot, and that's a good one to cover as well. And just like in the 3-axis Pro, in our 4-axis Pro here, we have, what do we have? The standard user interface versus the advanced user interface. So after we look at this simulation, we'll take a look at what the advanced user interface in the Pro functionality is for as well. So here it is, still roughing around these areas here. Still just going like at every step here, coming down the forced floor cuts. It's taken a lot of time to finish everything up in the roughing as it steps down like that. But then it it ends up with this as our final product for the roughing. And then the finish operation with the ball end mill follow along. And as I mentioned, you can see right here, this is a lot of material to remove for finish operation for the small ball end mill. So what we can do, actually I'll do it in the 4-axis. We'll do the number of intermediate cuts. Under the patterns page, down at the very bottom, number of intermediate steps, and I'm going to leave this, I'm going to change it from 2 to 3 here. And we'll compute that. This might take a few seconds. It's a lot of toolpath to cover. But while it's computing here, let me know if you guys have any questions of what we've gone over so far. We've gone through the 4-axis standard, and now we're going through the 4-axis Pro functionality of the advanced rough and advanced finish in rotary here. Almost there. Yeah, I couldn't think of like the cycle time and things like that now that we've done all this extra toolpath here. But we'll take a look at it here. If I go to simulation, let's save it just in case it wants to do something funny. I don't know if... Yeah, let me close out of it and reopen. I don't know why the simulation's not opening for me here. There we go. Sometimes it sort of locks up like that. Sometimes you got to close out the part file and reopen it, and simulation will run correctly. I've had it where you have to hit stop simulation and start simulation again for it to run correctly there. Just gets hung up on computing the toolpath sometimes. So that's usually my fix for it. So after it gets down to the very bottom here, oh, it's doing it already, isn't it? Yeah, here we go. So you can see the difference between the number of intermediate steps turned on and turned off. So if it's turned off, this is the depth of cut of 100 thousandths that we would have to remove with the ball end mill. That's a lot of material to remove with the finish tool. The number of intermediate steps is where it starts at the bottom here and works its way up. This is 1, 2, 3 steps in between each one of these 100 thousandths as it works its way back up the part. So that way, instead of 100 thousandths, it'll be what? 25, right? Because you've got 25 with 3 intermediate steps in between the 0 and 100 thou step there. Got to let it refresh here to see it better. But yeah, there we go. So that's 25 thou step in between here rather than the 100 thou from here to here that it's cutting now. And that's also found in the 3-axis roughing. So sort of like a semi-finish operation or like interim type of milling operation of between the roughing and the finish toolpath. You use your roughing to do an extra couple of steps to have a lot less material to cover for the finish operation here. And as we skip past the finish operation as it goes around the part, we'll see the finished product here like that. All right, and then let's see, what else is there? I think the only other thing to cover in the 4-Axis Pro would be all of the surface-based toolpaths. So I think this is probably a good one to cover here as well, because we have the advanced finish, which is sort of, you can see the tool marks here, it's sort of following along in a cylindrical shape. It doesn't follow along the pattern necessarily from here to here. So if we want to focus on a specific surface here, what I could do is one of our 4-Axis Pro operations. I've deleted them, so I'm going to just start from scratch. We'll do it live. So I'll right-click on the machine setup. I'll go to Mill Multi-Axis. And in the 4-Axis Pro, you'll see deburring, which will be in the 3-axis and 4-axis here, where you could use a ball end mill or a chamfer tool to be able to do a deburring operation. And also you'll have these surface-based toolpaths. My go-to, one we'll look at today, is going to be the morph between two curves. So I'm going to select one edge that I'm starting the toolpath at, and then the last edge of the surface is where I'm ending the toolpath at, and it will morph the toolpath between those two edges across the surfaces I select. We go to our tool page. We'll use that ball end mill. We'll open our parameters here. And we'll see this, actually, this is a great segue into the advanced UI. This is the same kind of advanced user interface you'll see in the 3-Axis Pro and the 4-Axis Pro. So first, I'm selecting the geometry on this page. Up at the top, you'll see first and second. So I'm selecting the first edges. So I'm going to focus on this surface as it wraps around. So I'm going to keep rotating this guy around and keep clicking on these edges here. If it lets me. There we go. There's an extra edge on that surface for some reason. Anyway, keep rotating this thing around. So this would be my first edge curves. And that would be my last one. So what I'm telling the software is that is where I'm starting my toolpath. I click OK, select second edge curves, and I'm just going to start on this edge across from the original that I clicked on. And it doesn't matter the order of how I click them. I could click on the edges in between in the middle of the surface first. This one actually looks like it's going all the way around, just a spline all the way around, which is cool. But yeah, it could be, I could select them out of order and it understands the geometry selection. Really nice for that one. And then I select my drive surface, which is going to be this one right here all the way around, and then click OK. And then set my step over. What I really like in these surface-based toolpaths and in the advanced UI we'll see later, I can set my step over, or I can have Bobcat calculate the step over for me based on the desired cusp height. So instead of going into simulation, making sure everything's cut to size, I can just type it in right here and know that everything's cut with a cusp height of no taller than 1 thou. So if I type in 1 thou, you'll see that the step over calculates to about 30 thou for me automatically. Next, I'm doing tool axis control is going to be 4-axis. We have our Gauss check page. We have linking for each step over. I'm just going to do a direct link as it steps across. And we do have a roughing option in here as well if you want to set, just like in the rotary toolpath, the number of roughing passes, how far they're going to be spaced out, and the number of finish passes and how far they're going to be spaced out. All right, we'll hit OK and then compute and see how this toolpath works for us. Pretty good for just doing it right on the fly here. You can see it spaced out equally from the first edge right here, going all the way across, and just following along from there. Instead of the 4-axis rotary, advanced rotary, it sort of follows as though it's following the cylinder. The morph between two curves follows the first edge that I click on here, or I guess it would be here, follows the first edge here and creates the toolpath following the surface that I selected. And that is under the morph between two curves. Now we'll take a look at one other one, which was the advanced UI, which is basically what we just saw in the morph between two curves. If I go back to my 4-axis advanced finish, right before I get to my tool page, you'll see it goes to this UI choice on this page right here. And it's going to ask me standard UI, which is the standard user interface, which is, selecting my tool, my patterns and parameters, lead in, lead out, all of those settings. Advanced UI, it's just going to open up that page that we just saw in the morph between two curves, right? It asks us for our machining surfaces, asks us for the axis of rotation, if I'm going around the part or along the part, if I want to go back and forth horizontally or around it. And you can see down at the bottom right, the maximum step over, or let Bobcat calculate that step over based on my desired cusp height. So I type in 1 thou here, and there's our same step over of 30 thou to follow along the part so that it gives us the same cusp height based on the same tool that we used of that 6mm ball end mill. Again, tool axis controls around the is going to be 4-axis, Gauss check page, linking for each step over, and roughing from there. So that user interface would be all of the pages that I would use rather than the standard UI. You can see all of those are collapsed now. We don't have the patterns parameters, leads, options, Gauss check. All of that would be built into the advanced UI. So both options there, whether you want to go the traditional route or if you want to go with the advanced UI for some of those extra settings like your cusp height option and other settings for trimming and extending your toolpath can be another option to manipulate your toolpath a little bit better in the advanced UI. All right, let me check my notes. I think those were the main topics I'm covering today. If you guys have any questions in the 4-axis milling operations, please let me know. Just went over the 4-axis standard milling operations, which include indexing, a wrapping group to make a pocket or do a profile or engraving around a turned part like this, and rotary, so that the tool can come down and the part will rotate around a rotary axis like this. And then we also went into the 4-axis Pro, where we have our 4-axis advanced rough and advanced finish, and also looked at some other ways to finish the surfaces a little bit better here in our 4-axis Pro surface-based toolpaths. And that's found under mill multi-axis here, and using the surface-based toolpaths like the morph between two curves. That's my main one. The other one that I use a lot would be Flowline, and you're selecting surfaces to machine along the side there. this one supports undercutting as well. So if you use a lollipop tool, you could do an undercut with this one. I like to show this one too. But yeah, if you guys have any questions, let me know in the comment section. I'll hang back for a couple minutes, see if you guys have any questions going through the live event today. I want to thank everybody for viewing the live event, and we do one of these every other Wednesday. So today's the 10th. I don't think we'll have one on Christmas Eve, and then the next Wednesday is New Year's Eve. So I think the next one actually is not going to be till not until January 7th. I think that's going to be the schedule there. We're going to skip Christmas Eve and New Year's Eve, and we'll have our next webinar on December 7th. That's going to be we always have we always send an email out to with a survey to see what you guys want to see in the next webinar here, so that we make sure that it's custom, tailored to your specific functionality you'd like to learn more about. But yeah, I don't see any more questions there in the comment section. So I just want to thank everyone again. Thank you all for viewing the live event today on MIL 4-Axis Standard and MIL 4-Axis Pro. This is recorded, so you can go back to the live event on this page at any time. And we hope to see you in the next webinar, January 7th. Thank you all. Have a great day.